Hey, hello guys, welcome to Network Peaks. This is Tangadurai, and in yesterday video, we have missed out, or I missed out few parts to explain. But the thing is, we know what is weight attribute, and we know how to configure, and also we know what is local preference, and we have experimented by doing the lab on R3 and R5, and we were seeing the output. It was following as per the we could see the output were as per our case study, as per our objective. So the thing, in last video we had a issue with the prefix R4, whatever R4 is advertising, right? The 4.4.4.4, the prefix. So here what we are going to do is we are just going to build the neighborship over their physical IP address, and so that even the 4.4.4.4 which we were not receiving through AS500 will be fixed once we fix this. So, and also this local preference, it is local to AS35 only. So, whatever the configuration you do regarding the local preference on any of the routers belongs to any of the AES will not be passed that particular information to any other AES. Let's say I had done the local preference configuration on router 5, that will be passed to router 2, but router 3 will not pass that local preference information to R4, because R4 is a different AES comparatively the R3 and R5, right? So that is one thing. So let's see here. Mm, where is router 3? Here it is. Let's see, show IP, BGP. So here we are still receiving the 4.4.4. network uh, through 5.5.5 as a best path, but we are uh, we are actually using this is as per our BGP, right? But this is not the final routing table. When you see show IP route, this is our final routing table. When you give 4.4.4.4, sorry, we can see it is known as static, right? This is purely a BGP one. Okay, it doesn't mean that this is the best path and this is the actual next of what it is using. No, we have to see what it is there on the routing table. Okay, so how it works actually, so whatever we see on the BGP, okay, this is purely based on the BGP. Whatever the BGP is receiving, it is going to work on those prefixes, and based on its algorithm it is going to find which is the next hop, which is the best path when there are more than one path is available to reach one destination prefix. So that is just a part of BGP, what it is doing in the BGP table. But once BGP find the best path, then that particular information will be passed to the routing table base. Okay, so this show IP route to see the routing table information, the final routing table information. So these are the only the paths will be considered when we have received a request to reach any of the destination prefixes. So as per this routing table, I have an entry statically defined to reach 4.4.4.4 via 34004. So let's remove that first. Okay, before removing, let me just show you that router 4 BGP table, it does not have any local preference, or basically doesn't do anything. Like this local preference information is not exchanged to another AES, right? Because we have configured it on R5, and that is only passed only to the internal neighbors. That means IBGP peers, not to the EBGP peers. So that is fine. So let's get back to R3, and in R3 Okay, I'm going to remove it, the static route. Okay, uh, so clear IP BGP star. Now the adjacency will go up towards router 4. When the R5 is up, R4 will not come up. Okay, sure, and section BGP. Let's go and remove the neighborship commands for router 4. Okay, and also let's go to router 4. Sure, and section BGP. And here in router 4, okay, let's remove the neighbor command for R3. Okay, so in order to do that, what you have to do, you have to just tell that no neighbor 3.3.3.3. This one command will remove all these three commands from the router BGP. So that's it. So neighbor 3 configuration has been removed from router 4, and from router 3 we have to similarly do it for router. We have to remove the router 4 configuration. So no neighbor 4.4.4.4. Simple. So let's configure it fresh. So we are going to peer based on their physical, the IP addresses configured on the physical interface, which is gig2/0. So here let me just go to neighbor, let me say neighbor 34, sorry, 3400.4, and remote AS is 400. And in router 4, I'm going to do that same, but here the BGP is 400 and my neighbor is 34003 and remote AS is 35. Now we could see the neighborship should come up. Show IP interface brief, include up. Okay, here we are seeing the neighborship has come up. Show IP BGP summary. The neighborship with R3 is up, and we are receiving two prefixes through R3. Let's go back to R3. Show IP BGP summary. Yes, if it is up there, it is up here as well. So pairing with R4 is up. And let's look at the BGP table now. So previously we were seeing the rib failure, right? R means a rib failure because the information in the BGP table is not a coincidence with the actual routing table. So that is why we are seeing this here. So here the 444 was learning, like the best path as per BGP is 5.5.5.5, right? But the it was showing rip failure. Let's see what is the status now. Okay, so the rip failure is gone, right, for 4.4.4.4. This 5.5.5 that you can ignore for time being, because again we have like for peering the router 3 and router 5, again we have a static route in place, and because of that, for reachability purposes, because of that this rip failure is here, but this can be ignored. Our concern is with R4, right? To for R4, the R3 was still choosing this particular link, even though we did path manipulation over BGP by doing local preference configuration. Let's check. Now R3 best path is via router 5, that is like this, to reach R4. Let's ping and check the connectivity is up or not. So it is up, and also let's do a trace route to check which path is being chosen. So this is choosing which path through R5. Our ping is successful, and it is confirmed that it is going via R5. So from our last video, we have fixed that issue, and so everything is working as per our case study. And just for remembering, local preference is local to the AS. If you configure local preference on one router, that will be exchanged to the IBGP peer, but not to the eBGP peer. But when we are comparing local preference with the weight, again it is local to the router, but it is not local to the AS like local preference. When you configure weight, it is just local to that particular router, right? So let's say if you have any additional router on that particular AS, even at that point, the weight attribute information will not be exchanged, even though you have IBGP peer. But in order to exchange those information, we have the attribute called local preference. So thanks for watching. We'll see you in next video.